This lesson covers finding domains of functions by analyzing an equation. We will start by finding the domain of the function f of x equals 2x plus 3. We can think of the domain of a function as being the largest set of real numbers x for which f of x is a real number. In this example, for any real number x, we can multiply x by 2 and add 3. The result will be a real number. So the domain of f of x equals 2x plus 3 is all real numbers, or in interval notation, the open interval from negative infinity to infinity. Next, we'll find the domain of the function g of x equals 2 over x squared minus 4. Since division by 0 is undefined, we need to look closer at this function, in particular at values of x that would cause the denominator to be equal to 0. So let's set x squared minus 4 equal to 0. Factor x squared minus 4 into x plus 2 times x minus 2. Set each of these factors, x plus 2 and x minus 2, equal to 0. And then solve the equations for x, giving us x equals negative 2 and x equals 2. Our domain needs to exclude the x values of negative 2 and 2. The result will be the open interval from negative infinity to negative 2, union the open interval from negative 2 to 2, union the open interval from 2 to infinity. And what we're looking at here is a domain that includes all real numbers except negative 2 and 2. Next, let's find the domain of the function r of t equals 2 over t squared plus 1. Again, we need to pay attention to the denominator. Let's set t squared plus 1 equal to 0 and see if there are any values of t that would cause a problem for us. If t squared plus 1 equals 0, this is equivalent to having t squared be equal to negative 1. Well, there is no real number t for which this is the case, so the domain of our function r of t is all real numbers, which we'll write as the open interval from negative infinity to infinity. Next, we'll find the domain of the function h of x equals the square root of 3x minus 2. We have the square root, an even root here. Only non-negative real numbers have real even roots. 3x minus 2 must be greater than or equal to 0 here. If 3x minus 2 is greater than or equal to 0, and we add 2 to each side of our inequality, we have 3x is greater than or equal to 2. Then multiplying both sides of the inequality by 1/3 would give me x is greater than or equal to 2/3. This will be our domain. All real numbers x greater than or equal to 2/3, which I will write in interval notation with square bracket, 2/3, comma, infinity, open bracket. Try this next example on your own. Find the domain of the function f of x equals the square root of 1 minus x. Lastly, we'll find the domain of the function f of x equals 1 over the square root of x plus 2. We have two problems with our domain here. One is having a square root. The other is having an x value in the denominator. So let's look at two different things. We want to make sure that the square root of x plus 2 in the denominator is not equal to 0, and we want to make sure that the x plus 2 under the square root sign is greater than or equal to 0. If the square root of x plus 2 is not equal to 0, it must be true that x is not equal to negative 2, and if x plus 2 is greater than or equal to 0, then x must be greater than or equal to negative 2. The intersection of these two conditions would give us x being greater than negative 2 as our domain for this function. In interval notation, this would be the open interval from negative 2 to infinity. In other words, all real numbers x such that x is greater than negative 2.